So R represents radius. Would that be considered linear? Or do you think that has to do with angular?
Angular.
Linear.
Angular.
Then if we measure the radius, that is a
Linear.
that's a linear unit. It's a measurement.
What is of a
It's
circle?
a distance.
But it's a straight line.
It's a straight line.
Okay.
Okay. And now, what is this one?
Angle.
Angle. But what? That's theta, and theta represents an angle. So what do you think?
I bet
That would be
Angular.
angular. So that's going to involve angular. We have something else that we'll get to later on, arc length, and we're going to study that in depth later. What do you think little t stands for? Time. Okay, so we have v, which is velocity. Generally, just a v by itself refers to linear velocity. And then we talked about angular velocity already in our little story about big trucks. All right, so angular velocity is described by the Greek symbol that kind of looks like a kind of curly cute W. That's an omega.
What?
Omega, it's a lowercase omega.
Yeah. What's
the upper
A capital omega?
It's like an upside down horseshoe.
Oh,
Yeah.
yeah.
Yeah, that was in my sorority. My
Oh my
sorority
God.
was this.
What does that stand
Ooh, part here.
Alpha.
for?
What is that?
Is that a part?
It's alpha something omega.
It is Alpha Chi.
Alpha.
Alpha Chi Omega.
Chi.
Yeah.
I'm in the theta omega.
We're not.
That's not a thing.
You're in the
I'm in a math.
you're in the math. Okay.
Omega just like a double.
It is like a. I'm not good at drawing it, but it does kind of look like a curl. A curl in W. Yeah. Yeah. All right. So if we define those and then we look at the formula, we know linear velocity is our distance traveled over time. And angular velocity. This is new, but it makes sense. Angular velocity is defined as the number of radians that the angle changes over the time elapsed. And these are angles of rotation, which is what we've been studying. Okay? So this formula would look like this. It would be angular velocity equals theta over time. Okay, so today we're just going to start working some problems. We're going to do most of the front of this worksheet together, and then you have the back to do on your own. So as we work through these, your guys are going to go, oh.
This is easy.
Those of you that have studied stoichiometry are going to be like, this just looks like I'm setting stuff up and making units cancel to get what I want. Well, it is. It is. I thought this was, when I studied this in high school, it was like a reciprocal game for me. I was like, let's look at what they gave me and what they're asking for. And then I just have to figure out how to get from where I'm starting to the finish point.
How do you start something?
I look like I'm trying to lose weight.
I'm breaking it.
Are you cutting or cut?
What I'm gonna do is this Friday, or next Friday.
You were.
Okay. All right. Problem number 1. Here we're talking about a wheel, and the wheel turns, and it gives us 34 radians in 3.2 seconds. Well, before I even get to a question, and I see radians, and I see seconds, and I see a wheel turning, I'm thinking angular velocity. And then guess what they asked me? What is the angular velocity? Okay, so revs per minute. Revs is an abbreviation for revolutions, right?
RPMs.
Okay? And that is RPMs. Have you ever seen that? Where do you see RPMs?
Oh my God.
In your car. Okay? When you look at the dashboard. Right? Do you ever watch it change?
When you push the gas really fast, it goes up.
Do any of you drive a manual or a stick shift car?
I have.
We've got one. We've got one. It probably has more meaning for you guys.
I don't.
Because you
When I
can
drive
hear it.
engines and I
Do you
almost-
hear
I
it?
drive.
When the RPMs increase and you know it's time to switch gears. Yeah? You can hear it. You can feel it too. You know when it's time. All right. So let's look at where we're starting and where we're heading. Okay, we're starting with, I'm starting with 34 radians. And I'm going to abbreviate that rads in 3.2 seconds. Okay, so that's what I'm starting with here. And I want to end up with revolutions in a minute. So this radian needs to convert to a revolution. Let's think about that. In one revolution,
There are 2 radians.
there are how many radians?
2.
2 pi.
2 pi.
So this, to convert, I want revolutions in the numerator and 2 pi radians because that is its equivalency in the denominator. Now that is what I want because I wanted radians to go away. And because I put 1 in the numerator and 1 in the denominator, they did cancel. Okay, so now I've got revolutions over seconds. So I'm not quite there. That seconds needs to be minutes.
So you multiply it by
Okay.
60.
So we know there are 60 seconds
Oh, now this is chemistry.
in 1 minute. Okay, so let's see what cancels now.
Second.
It appears that seconds cancel. And then I'm going to take a look at my units. I'm left with revolutions in the numerator. Check. Minutes in the denominator. Check. Okay, now I just need to do the calculation. So I multiply everything in the numerator, divide it by the product of what's in the denominator. Calculators, please.
I don't
Wait,
Shouldn't that be like 2 different stoichiometry problems? One for the change in time?
No, you don't have to.
You don't have to here.
Okay.
Nor do you have to.
Yeah.
Should we
Because we
multiply
don't
by
have
pi as in the
Or keep pi.
number or leave pi on its own?
Go ahead and multiply it. Okay, so the question was, is it necessary for me to leave my answer in terms of pi? No. Go ahead and multiply pi in.
I did.
Okay, so you get approximately how many revolutions per minute?
1,001.
101.
Wait, how do you get rid of pi? You divide it by pi?
1,000.
You got 1,000? I got 101.
Yeah, I got that.
You must have left off something.
I got 101.46. One.
Check your math. Check your numbers.
How did you say you get rid of pi?
You just do 2 that. Like 34,000
Oh.
divided by that.
Oh, okay.
Just multiply it with it.
Multiply the numerator.
Got it.
with
You?
that. Multiply the
I
denominator
do.
with that. Or no. You're like,
I gotta turn my shoulders.
so awkward.
I can't turn my foot.
Okay, so any questions about number 1?
No. Wait, Miss Willoughby, I'm.
All right, so let's talk about what that means. What does that mean? What does that mean about this wheel?
Means that it turns 101 however many times in a minute.
That is. That's exactly what it means. It means that this wheel would do 101 plus a little decimal complete revolutions in 1 minute.
Oh, 1 minute.
Yeah. Okay. All right. Let's take a look at number 2. Yes.
That's
There was a
actually
question?
really slow RPM.
It was not.
It's 100 RPMs. Her car does like 2,000.
Not if it was a bicycler.
That's what I'm saying. See?
Oh.
Physical
My bad. Did you just hit
All right.
me?
No.
You said
Number-
no touching.
Number 2. Number 2. All right. A drill.
I forgot.
All right. A drill is going 340 radians per second and goes 12 radians in how much time? If it goes 340 radians per second, how much time does it take to go through 12 radians? Very little, doesn't it? If it can do 340 in a second, it's going to be a very small portion of a second. Now, we certainly can set this up the way we just did. We want our answer to be in time. What's our time unit in this problem? Seconds. So what does that tell us we need to do with this 340 radians per second?
What do you know multiply by?
Divided by 12.
We need to do the reciprocal, right? So if we set it up just like the other one, which is one method, maybe not the best, but it is one, then we want time, so we will multiply by the 12 radians, and guess what happens? It cancels. And so my time would be 12 divided by 340.
Divided by?
Yes.
So you wouldn't cross multiply?
We only cross multiply if there's an equals between them,
That's multiplication.
and it's just straight out multiplication. There's an equals after. So that would be approximately,
Like 0.0353.
yes it is, 0.0353 seconds. Now, definitely not the only way to do this problem. We could go back to what we know about angular velocity. Angular velocity equals what?
Theta over time.
The number of radians.
And we could just solve for time. So time would be theta divided by omega, right? If we solve for time. So time would be 12 divided by 340. Is that what we just did? Yeah.
Why is 340 the W?
It is the angular velocity.
It's not radians.
It is the radians per second. That is our angular velocity.
Crikey. Crikey.
Okay. Questions about 1 and 2? I think it takes a couple for these to make good sense. Those of you that have already been exposed to the process in stoichiometry probably have a leg up. Those of you that have seen some of this from a physics standpoint probably already have some prior knowledge that you can attach this to. And then for the rest of it, it's just plain new. So I don't want to go too fast. So stop me if I'm going too
I
fast.
knew there was going to be some.
All right, so number 3. Number 3 says, what angle in radians does a car wheel with a 35 centimeter radius turn if the car travels a distance of 12 meters? Okay, now, does it make sense that the distance traveled in one revolution of a wheel, that distance, that linear distance that it travels, would it be equivalent to the circumference of the wheel? Okay, so how is that helpful? Okay, so what is the angle in radians with a radius of 35 centimeters if the car travels a distance of 12 meters? So we know that one revolution for this car, one revolution is going to equal what distance? It's going to be 2 pi r, isn't it? And what is r in this case? 35 centimeters. Now, we have some choices to make because we've read the whole question twice. We know that one of our units is in centimeters and the other is in meters. So my choice would be at this point to go ahead and convert centimeters to meters.
Call it 0.35.
So it would be 0.35. So I would go ahead and make that conversion here to help myself out later. Okay, so I know this is an equivalent. Did y'all get approximately 2.199? Okay. Yes.
I just had a question. When I'm in my car and I turn it on, and like I'm not actually moving it, but the RPM's still above 1. But I'm not actually moving, so the wheel's not moving. How's that?
Oh boy.
I'm just
I don't think the clutch is engaged.
I think that's just how it works.
You're not supposed to ask questions. You just
Well,
Okay.
Okay.
Like, we see the
No, I was just wondering. I just didn't get that tonight because I figured this. We're talking about wheels rotating.
this is when I really wish my husband was here.
You know what I'm talking about?
Because
don't
I
you?
have the book smarts and he has the know-hows. You know what? I will get back to you with that question.
Thank you.
I think that's a very valid question. And I will research that. Alright.
I would like to hear it all the time.
Okay, so we have 12 meters, right? Okay, so that's what we're starting with. And we want to end up with radians. Somehow. Down here. We want to end up with radians. Now, we just came up with this cool conversion right here. That 1 revolution equals 2.199 meters.
Where do we get the 12?
That's the meters
In the
of
problem.
this.
It's given to you since.
Oh.
Okay? Now that helped me get closer because now meters are gone. But now I'm stuck with revolutions and I want to end up with radians.
Multiply by.
Divide by.
Is there any equivalency between revolution and radian?
2
Two pi, right?
2 pi.
Yeah.
2 pi.
Rad.
2 pi. That's not hard.
Okay. So we know that one revolution better go down here, right? One revolution is equal to 2 pi radians, isn't it? Okay?
Revolution goes in the bottom.
Well, it had to, because I want revolution to go away.
I get it.
And currently it's in the numerator. All right.
And the only reason you can do this is because it's basically 1.
All right, so let's see what you get.
34.2.
That's correct.
12 times.
Oh, it'd be 12 times 2 pi over 2.
Now, guys, if we hadn't have already multiplied this out, if we had left this 2 pi 0.35, do you see that I also could have canceled the 2 pi's?
Yeah.
And so see what you get now if you do 12 divided by 0.35.
I didn't get that. I got like 7.
Check your parentheses. Gotta have big old parentheses here, big old parentheses there. This times this times this divided by this times this.
Right.
Does it matter if you're in degree or radian?
No, it doesn't.
I didn't get this in. Because I'm not. You put the quizzes in already, right?
Blackboard did it for me.
2 times pi. Answer. Divided by.
Okay, so did you notice that if you just did 12 divided by 0.35, we would have gotten the same thing? Okay. All right. So that tells me, in number 3, that is the angle in radians. 34.286. Now that's an angle of rotation, right? All right. Number 4. Number 4. A roller blade wheel is 3.2 centimeters in radius. So that's the radius of my rollerblade wheel. What is the angular velocity and radians per second of the wheel if you were going 14 meters per second? All right, so I'm starting off with 14 meters per second, and I want to end up with angular velocity and radians per second. All right, so I need to change this 14 meters into radians.
Well,
Well,
Let's rock it out.
if
You multiply by 2 pi.
Divide by 2 pi.
Okay, so the first thing I want to do is take that one relationship I have about the revolution of the wheel and the distance it travels. Because that distance it travels is how I can eliminate a distance, right? So that would be 2 pi r, and I'm going to plug that 2 pi r down here. And r in this case is what? 3.0, but that's in centimeters. So it'd be 0.032 meters. Okay? So this gives me revolutions. So this is my connection between a linear into an angular.
And we get that from the circumference equals.
Yes. One revolution of the wheel is the same as will travel the distance of the circumference of that wheel. Good. All right, and now we have to change revolutions into radians.
You times it by 2 pi radians.
So 2 pi radian equals 1 revolution. All right, let's see how we did. So meter is going to cancel with meter. Revolution with revolution. I am left with radian and seconds. I'm good. Oh, I can also, you are correct. Let's go ahead and do that.
Where is Alabama?
But why don't the 2 radians cancel?
There are no 2 radians.
This is a radius versus a radian. A radian is that, yeah, angle measure.
That is right.
4,600.
That says 437.
That's correct.
Oh, it is?
437.5.
0.6. Where did, I got 0.6. 3, 4.
I just got
You.
I did 14 times 2 pi.
All right.
And then divided out.
Divided by
14 divided by
14 divided by 0.0.
The 2 pi's did work. We were able to cancel
So
this
you
one.
say, well, you can, if you multiply by pi, the calculator only has so many digits of pi. So that would be why.
So you did 14 times 2 pi divided by, where did that 0.201 come from?
I did that.
Is that 2 times pi times point?
Yes. Okay.
0.032? That's because it has this extra. That's why it's slightly different.
I didn't figure that out.
You're close enough.
He's touching me.
All right, now, let's take a look at part B. Part B asks for revolutions per second, guys. Which is actually a little less work than we just did. Okay. Which parts do I need? 1, 2, 3. Which ones do I need to get me to revolutions per second?
1 and 2.
1 and 2. That's all I need. I just need those 2. If I did 14 meters over seconds times 1 revolution and 2 pi 0.032 meters, that gives me revolutions per second. All right, let's find it. A little less work. A little less work. That's nice.
Beautiful. Well, actually, oh wait, no, beautiful. But,
Ew.
69.63.
That's right.
Wait, what? Oh, never mind, actually.
Wait.
You got it?
I see what I did.
Okay. Good. And then the last one's even easier because it just asks us to convert it to minutes. So if we take this 69.63 revolutions per second, and we just want to convert it to revolutions per minute, all we have is what?
60 seconds.
60 seconds in 1 minute. And what does that give us approximately?
4,179.1.
Good try.
I must have left my digits in there.
I got
Yeah,
50.
4,000.
I rounded.
Okay, okay.
Now that's an actual
I
car.
got
Okay, actually, I'm wrong, okay.
In my car, that'd be going
Yeah.
accelerating pretty fast.
Yes.
I hit 92 earlier on the question.
Okay.
Yeah, I'm just kidding.
Number 5. I want you to go ahead and read the problem, okay? So a little less guiding you through it on this one. Everyone, please read number 5. And let's see if you can start to set up this one on your own.
Why is it here?
Okay, so we want to end up with angular velocity in radians per second. Okay? But what we started with was revolutions per minute. Do you see they started us with revs per minute? So the easy conversion is minutes to seconds. What do I do? 1 minute equals 60 seconds. So 1 minute over 60 seconds. So now I am good with my unit for time. Okay, so now how do I turn revolutions into radians? We know 2 pi radians equals 1 revolution. Hey, I'm done. And I didn't even use that extra piece of information I was given.
It's a trick.
Because it was extra.
Oh well, that actually got me.
Okay? So this should, did you say 125? Yes. 125.664, excuse me. All right. So the radius is not going to change the angular speed. It will change the distance we travel. Yes, sir.
I added in another stuff and got the same. But I used the 0.12 meter.
And then you eliminated it.
Yeah, I did
You
that.
used-
Okay.
You put it in and you pulled it right back out.
So that's okay though.
It's okay.
That works.
Just a little more work than you needed. Yep. You put it in and you took it right back out.
How did you manage to do that?
Okay. Number 6. The back is homework.
Woo, baby.
All right, number 6. Let's see what you can do without me at all.
Maybe that's why he has
Poor Johnny.
Maybe that's why he has such a
That's right. He got flung off the merry-go-round.
Are you gonna keep it?
You're trying number 6.
I'm doing number 6.
Oh, what's meters?
Alright.
Does Johnny
Alright.
love
So, when I was in elementary school, we had to learn all of our conversions. And the one I remember is that 1 kilometer equals 0.62 miles. So I remember this one. I'll share it with you. It's approximately 0.62 miles. Yeah, that's the one I remember. And then I remember all the other standard conversions, like there's 5,280 feet a mile, 1,760 yards in a mile.
I didn't know that one.
We were
I
told to
thought it was
memorize them.
1,601 meters in a mile.
We were told, huh?
This is 1,601 meters.
Oh, what?
5,280.
I said there's 1 kilometer is 0.62 miles. I didn't learn it the other way.
I know 5
The reason we learned it that way is because I grew up having a very good understanding of our measurements, so I understand what a little bit over a half a mile is. If you say so many thousand meters, I don't know what that means.
All right, this is the moment of truth. 5 times 6 times 6. nervous. I'm really nervous.
That's fine.
It's like a road. It's too slow miles per hour.
If Johnny had a helicopter parent, he'd have on a helmet.
Or not be known.
That's true. Do you know there are very few playgrounds that still have merry-go-rounds? Those were my favorite too.
Well, they also really
I love
I
it
guess
when
they're
I
really
flew
dangerous.
off and hit a tree.
Well, because it felt cool on
Yeah.
it. That
Did yours
yeah. That's why they were my favorite.
It's the only legal drug in the world.
Well, I felt like I was flying. You know, like if you were the one pushing the merry-go-round and you ran and ran and ran and then you jumped to get on it while it was round.
Yeah.
That was
I felt like I was flying during that jump.
And then you spray for union.
Ah, who cares?
It's like you were jumping, the thing was carrying you forward.
I know. All right.
You gotta get like 6
Wait,
feet
wait,
closer
wait,
at
wait, I'm
once,
almost
then
there,
you
I'm
try to
almost
hang
there.
on while your feet hang off.
No. No neighbors. I've got
All right. So we're starting with 5 radians per second. And somewhere along the way, we're going to convert that to miles per hour in mph.
I got it.
All right. Set. What else do we have? We have a diameter. The diameter of the merry-go-round is 6 meters. So the radius would be 3 meters. All right. So, the one thing I can think of off the bat is 2 pi radians equals 1 revolution. Was that helpful? Let's try it. 2 pi radian is 1 rev,
Yes.
and then 1 rev
Is one circle.
is what?
6 meters.
6 pi meters.
Okay.
6
Six.
pi.
6 pi meters.
Say that 6 pi meters is equal to 2 pi revs. Because I skipped the revolution set.
Why not?
Yes. 2 pi rad. Yes. Yes.
All
right.
Well, I gotta say,
Could you do
So now I'm in meters. So I have to change meters to kilometers.
It's 3
So 1 kilometer
equals
is 1,000 meters. And then
0.62 miles.
0.62 miles
that's cool.
is 1 kilometer. All right.
60 seconds in.
Okay. And then there are 60 seconds in a minute, and 60 minutes and an hour. I think we did it, folks. All right, let's
33.48.
carefully and slowly. All right, rad, rad, rev, rev, meter, meter, kilometer, kilometer. Oh, that was miles. Mi. Sorry. So I'm left with miles. Good. Okay. Now let's do my units for time. Second, second, minute, minute. I'm left with hour. Okay. So that should do it.
30.62 miles per hour.
Okay.
No, 33.5.
33.48 miles.
Thank you.
Yeah, why is he moving so fast?
Alright, so he was ejected. I'm really hoping he landed in a really soft pile of leaves. Okay?
That happened to me. I hit a tree and I never went back. Flew off and hit a tree.
Alright, guys.
Same thing on the.
And the backside. Go ahead and see what you can knock out in the next couple of minutes. And then probably during lunch next Monday, somebody's going to go, did you do your math homework? And you're going to go, and then you'll do it.
Yes, of course.